Today we're going to learn about solving equations with absolute value. Before we get into any examples, let's just talk a little bit about what absolute value means. And a great way of thinking about it is the absolute value of a number may be thought of as its distance from 0. And what that means is, if we take a number, let's say 3, and we want to know what its absolute value is, and let's say we want to also know what the absolute value of -3 is. These are absolute value bars, by the way. What I'm going to do is I'm going to draw a number line, and I'm going to count from 0 how far away a +3 is. So if I start at 0 and I want to know the distance between 0 and 3, I'm going to count 1, 2, 3 units. So I can say that because the distance between 0 and 3 is 3, the absolute value of 3 is 3. Well, if I want to know what the absolute value of -3 is, I'm going to do the same exact thing. I'm going to start at 0, and I'm going to calculate the distance between 0 and -3. 1 unit, 2 units, 3 units. So the absolute value of a -3 is also 3. And you might be wondering, why is the absolute value of a -3 3 when you're going in the negative direction? Well, for those who are asking that question, I want you to answer this question. Have you ever ran -1 miles? If the answer is no, you're correct. Whenever we talk about distance, we're not talking about the direction we're going. We're just talking about how far we've gone. So with absolute value, the absolute value of numbers are always going to be non-negative, okay? Meaning they're never going to be negative. Because when we talk about distance, we only really phrase it in the positive sense. So here we're going to start with the absolute value of 7 times v equals 63. Well, I know that the absolute value here is 63. And I know that there are two numbers on our number line that are 63 units away from 0. One of those numbers is 63. If we were to count from 0 all the way to 63, we'd count 63 units. The other number is -63. If we started at 0 and we counted how many units between 0 and -63, we would also count 63 units. So I know here that the absolute value of a -63 and a +63 will result in 63. Well, what number times 7 gives me a -63, and what number times 7 gives me a +63? If I didn't know how to do that in my head, what I would do is I would take what's inside the absolute value bars, and I would set it equal to -63. Solving this equation is going to tell me what number times 7 gives me -63. And if I wanted to know what number times 7 gives me a +63, then I would do the same. So now we're just going to solve this one-step equation for our variable, which in this case is v. Here I'm going to divide because these two are being multiplied. I'm going to divide by 7. I'm going to divide by 7. V equals a negative divided by a positive is a negative, and 63 divided by 7 is a 9. So I know that -9 times 7 is going to give me a -63, and the absolute value of -63 is 63. Well, there's also another value, right? This value right here that we're about to solve for. So we're going to do the same exact thing. We're going to divide by 7, divide by 7. V equals a positive divided by positive is a positive, and 63 divided by 7 is 9. So we also know that 9 times 7 gives me a +63, and a absolute value of a +63 is also 63. So I'm going to type in both these answers into my blank, and the directions state that I need to type in the smaller value first. And in this case, the smaller value between -9 and +9 is a -9. Question number 2. So here we have 2 plus what number results in, or should I say numbers, result in the absolute value of 5? Well, I know that if 5 is my absolute value, there's two values that give me the absolute value of 5, -5 and 5. So in order to figure out what number is going to give me a negative 5, I'm going to take 2 plus n, or whatever's in the brackets, the absolute value bars, set it equal to negative 5, and 2 plus n, and set it equal to 5. Now I'm just going to solve each one. This is also one step. 2 is being added to n. In order to eliminate this, all I have to do is add the opposite number of what I want to eliminate. Negative 2 and 2 eliminate to 0. I've got to make sure that I add the opposite number here. Okay. If you want to simplify the double sign, go for it. Negative 5 plus a negative 2. Well, I'm adding negatives here, so I know that's going to be negative 7 equals n. And I'm going to do the same exact thing to isolate n, which is add the opposite of a 2, which is a negative 2. Those simplify to 0. And add the opposite here. I'm going to simplify it to subtraction. 5 minus 2, n equals 3. So which one goes first? Well, negative 7 is smaller than 3, so I'm going to type in negative 7 and 3. Example number 3. X divided by 5, or the absolute value of x divided by 5 plus 6 equals 8. Well, in this example, here we have this plus 6, which is not inside the bracket, right? So what do we do now? Well, I want you to think back when we learned about this idea of reverse Pemdas. SAD MEP. And when we did SAD MEP, what we did is we eliminated things that were being added, subtracted. Then we focused on eliminating multiplication and division, exponents, and last we focused on parentheses. I want you to think about these absolute value bars as parentheses. So what we're going to do is we're going to save this for last. Before parentheses, what we can do is eliminate addition, because if we work backwards, addition comes first. So if I want to eliminate this 6 that's being added, I know that I need to use inverse operations. The opposite of adding a 6, or the opposite of 6, is a negative 6. So I know that if I add a negative 6 to both sides, it will eliminate this positive 6 right here. And I'll be left with the absolute value of x divided by 5 equals 8 plus a negative 6 is 2. Okay, now I know that the absolute value numbers in here that will give me a absolute value of 2 are negative 2 and positive 2. So I'm going to do x over 5 equals negative 2. X equals 5, a positive 2. And I'm just going to use inverse operations to solve. The inverse of division is multiplication. I'm left with x here. Negative 2 times 5 is a negative 10. And I'm going to use the same inverse operation here to eliminate this 5 that's being divided. X equals a positive 10. Which of these two values is smaller? We're going to type in negative 10 first. Very similar. We've got a number that's on the outside, right? And before we eliminate the parentheses, or in this case, do the absolute value bars, we've got to eliminate this. Since there's no operating sign between the two, we know that they're being this negative 2 is being multiplied. Well, the inverse of multiplication is division. What do I want to eliminate? I want to eliminate negative 2. So I'm going to divide both sides by negative 2. What I'm left with is the absolute value of 3 plus x equals positive 1, because a negative divided by negative is positive, and 2 divided by 2 is 1. Now I know that the two numbers in here that will result in the absolute value of 1 are negative 1 and positive 1. I'm just going to solve using inverse operations. 3 is being added. How do I eliminate a 3? Well, I just add the opposite, which is just a negative 3. Add the opposite here. Negative 1 plus a negative 3, that's a negative 4. And I'm going to add the opposite again. You'll notice that you're essentially doing the same operations to both equations. You're just getting a different value sometimes. Adding the opposite is the same thing as subtracting. So I have x equals negative 2. Which of these two values is smaller? Well, I know that negative 4 is smaller than negative 2. If I owe somebody $4, I'm a much poorer guy than if I only owe somebody $2. Great. Here we have the absolute value of x minus 5 equals 5, all divided by 7. Well, if I'm working backwards with PEMDAS, I'm going to save my absolute bars for last, and I'm going to get rid of this division with multiplication. Divide, that's gone. One absolute value of x minus 5 divided by 1 is just absolute value of x minus 5. I gotta make sure I multiply the same exact thing to the other side. So what I'm simplify my equation to is just the absolute value of x minus 5 equals 35. And I know the two numbers that will give me the absolute value of 35. So I'm going to take my x minus 5 and set it equal to negative 35. And I'm going to take x minus 5 and set it equal to positive 35. Now I'm just going to use inverse operations here. The opposite of a negative 5 is a positive 5. When I simplify these, I get 0. Same here. And I get equals. If I owe somebody $35 and I only have 5, after I pay off what I can pay them, I still owe them 30. And the same operation up here. Add 5, x equals 40. Which one of these is smaller? We know that negative 30 is smaller, so I'm going to type that in first. Here we have negative 7 plus the absolute value of 3x minus 3. If we're working backwards with Pemdas, we're going to eliminate this before we eliminate our absolute value bars. So how do I eliminate a negative 7 that's being added? Well, if I want to eliminate a negative 7, all I have to do is add a positive 7 or add the opposite number. Make sure I do it to both sides. What I'm left with is just the absolute value of 3x minus 3 equals 12. And I know the two numbers that result in the absolute value of 12 are negative 12 and positive 12. So I'm going to set what's inside the bars equal to each number and then just solve for my variable. Watch me do this two equations at the same time. Sometimes you get the same value, or you get the negative value and the positive value, but sometimes you get two different numbers. So first thing I'm going to do here is I'm going to add 3 to both sides. Can't really fit it in. Here we go. 3, add 3, add 3. Simplified here, I know that those two terms are going to eliminate, so I'm just left with 3x equals negative 12 plus 3 is a negative 9. And here we have 12 plus 3. So after those two terms eliminate, we have 3x equals 15. And here we're going to divide. And we have x equals negative 3 and x equals 5. Which of those is smaller? Well, negative 3. Okay, so before we, again, we're working backwards with Pemdas. Before we eliminate what's inside, or the absolute value bars, or the parentheses, whatever, we're going to eliminate what's on the outside. In this case, this negative 3. Since it's being multiplied, we're going to divide this entire side by negative 3. Same thing to the other side, divide by negative 3. Now what we have is 10x minus 4 equals, a negative divided by a negative is a positive, and 42 divided by 3, well, 3 doesn't go in, 3 goes into 4 one time, with 1 left over, and it goes into 12 4 times. We know the two numbers that result in the absolute value of 14 are negative 14 and positive 14. So I'm just going to take what's inside my absolute value bars, set it equal to each of these numbers, and then solve for my variable. Okay, so here it's easier to eliminate this subtraction first. So I'm going to add 4, and what I get is 10x equals negative 14 plus 4 is negative 10. And I'm going to divide by 10, x equals a negative 1. Same thing here, I'm going to add the opposite of a negative 4, which is a positive 4. And I get 10x equals 18. And I'm going to divide by 10, x equals 18 divided by 10 can be simplified because each number can be divided by 2. So I've got 9 over 5. Well, which number is bigger between negative 1 and 9 over 5? Well, negatives are definitely not bigger than a positive, so I know that negative 1 goes here, and 9/5 here.